So first off, I just want to say it's a pleasure to be here. And wow, that light blinds me entirely. I'm here to represent California and Texas, and I know given the geopolitics, that's always a dicey situation, especially with the friendly rivalry between the two governors of the states, but I will do my best to just present to you about what some of the capabilities that we have in the state of California. So I'm not here to represent one particular aim or one particular goal. I'm going to be talking to you about some of the installed capability and expertise in the state of California and some of the leadership activities that we have in building the bioeconomy for the state and beyond. So I also take you on a little tour in history of the national labs writ large. Berkeley Lab was the first national lab. Okay. That won't do anything. Berkeley Lab was the first national lab. If you saw Oppenheimer, the movie, that was the creation of Berkeley Lab that happened at the beginning of the Manhattan Project. And it's been around since, that time period. What people may not know is that E.O. Lawrence's brother established biology at Berkeley Lab simultaneous as the establishment of the nuclear program there. And that's because they wanted to study the impact of nuclear radiation on biological systems. And that also led and culminated in the Human Genome Project that led to the revolution in genomics that came out of that entire effort. Lawrence Livermore is a physics lab. It was also a way to keep E.O. Lawrence involved in the PIT project, shall we call it. And they have some massive infrastructure, the National Ignition Facility. They have a very strong program in biodefense and homeland security. And there's a lot of synergies and dual-use applications around biology and biotechnology that you can use it for both the promotion of the bioeconomy and the growth of biological systems, but it can also do it to build better sensors and monitors for the protection of the taxpayers, which is also a good thing. Sandia National Lab, California, here's where we get into the history. Back when Los Alamos was stood up, the Z division was the engineering support for all of the physicists. That became Sandia National Laboratories in Albuquerque. When Livermore was established, because they wanted to keep E.O. Lawrence involved and he wanted to leave New Mexico because he hated it, Sandia National Lab, California came out and co-located with Livermore side by side. And so that's why we have these three national labs within the state of California that are all from the offshoot of the Manhattan Project. That said, Sandia National Laboratories, California has a very strong program in biology. They were leaders in the algae biofuels program, and all of them are committed to developing new synthetic biology tools that can be used for the deployment of systems out in the bioeconomy. And last but not least, we have the SLAC, which is a Stanford Linear Accelerator. And that is just a huge beamline that does really high-end physics work that's also important for biology and understanding protein DNA interactions, transcription, translation, and the like. So it is rather unique for one state to have 4 national labs. There are only 17 DOE national labs in the nation, and so 4 of them co-located in California and pretty close together in geographical proximity is a really enabling of some catalytic synergies between them. And in particular, in terms of the bioenergy centers that are there at all the labs, we have the Joint Genome Institute, which involves Lawrence Livermore and Hudson Alpha. It is the world's premier genomics facility for anything not related to humans. In the United States, if you wanted to have a human genomics center, that would be the Broad Institute. But this institute has been responsible for all the plant genomics that have gone out into the public domain and been used for its open source platform for genetic engineering. It is pioneering in the role of microbial and microbiome genetics and environmental samples, and it is a user facility, meaning that all you need to do is write a proposal, get it reviewed, and then you can get it done for free. There's no cost for recharge on it whatsoever. So, and it's got a user base that is numbered in the thousands, and it is a rather remarkable facility. Glenda, are we good to go? We're good, okay. So now I am not stretching. I'm going to just be the fill gap here. And then we have a remarkable facility called the Advanced Biofuels and Bioproducts Process Development Unit. That's located at Lawrence Berkeley National Lab. It was stood up with ARA funding back in the day, and for about a $17 million investment initially for capital expense, we've created a collaboration facility that works with startups and mid-cap industries to de-risk biotechnology platforms. They can go all the way from feedstock, breaking that feedstock down into intermediates, be it sugars or lignin-derived intermediates, and then feeding those intermediates and hydrolysates into organisms up to the 300-liter scale of volume. It has been a pivotal facility for the bioeconomy writ large. It has worked with over 100 companies. It has resulted in the launch of 14 commercial products that you can buy at Costco and Target. And it has resulted in over $2 billion of private investment going into those startups that have de-risked their technologies at this facility. So the return on investment, overall it's been about a $27 million investment from taxpayer funding that has resulted in greater than $2 billion of private funding. So that's a pretty good ROI. It has also expanded the gamut in terms of what success looks like in tech translation centers. It is a model that is often emulated and replicated about how to build a test bed facility that can further promote scaling of biotechnology solutions across the nation. And there are several developments underway that are basing their progress and their schematics and their approach on the ABPDU. Finally, we have the Joint Bioenergy Institute. It is an organization that is funded by the Department of Energy Office of Science. It is all about lignocellulosic biofuels and bioproducts. It is looking at new ways to convert feedstocks that are derived from terrestrial crops and like trees and dedicated energy crops like switchgrass and miscanthus, and converting those into things like sustainable aviation fuels, high-performance polymers, chemicals, et cetera, et cetera. It is 14 different entities that participate within JBay. It has been a generator of over 15 startup companies that have come out since its incept date of 2007, and that have gone on to be very successful in the field, and not only just in biotechnology, but also things like AntiBio, which is a sequencing company that is doing some rather remarkable thing in enzymatic sequencing that is changing how sequencing is done at scale. All these national labs have incubators that are for startups to come in and do the first early days. So at Berkeley Lab, there's Cyclotron Road, which has been a very successful program. You can see some of the companies that have come out of all these on the right. You know, very familiar names: Amyris, Fasolis, Mango, Lygos, Solugen, and Titan Bioenergy. Sandia Livermore and Lawrence Livermore have a really unique facility called the Livermore Valley Open Campus. This was really hard to do for them because they are NNSA labs, National Nuclear Security Administration labs. So they're really not cool with being transparent and open about what they do. They like to keep it very closeted and very controlled and all the information flows that come out of it. So the fact that they were able to dedicate a parcel of land that spans the two sites and call it the Livermore Valley Open Campus and allow it to go unfettered in terms of startups coming in and using the capabilities at those two national labs to promote their business models was really remarkable. And I give credit to the leadership teams at both of those national labs for getting to work and work so successfully. So finally, let's go into some of the economic and industry impact. The national labs have, in recent events, learned the value of being able to communicate why they matter to the economy. There's been a lot of questions about that recently. So if you just take a look at it, it's been a lot of startups that have come up, over 150. That CRADA number is woefully out of date. It was something that's taken over the past 3 years. CRADAs are contracts by which the national labs can partner with industry to de-risk technologies and work on something collaboratively. It's a collaborative research and development agreement. And since their beginning, I would say there's well over 500 CRADAs that have been there, but we just did a data slice just for the past 3. We've created 20,000 direct and indirect bioeconomy jobs just in California alone from the projects that have come out of the national labs. That's not direct hires through the labs. And we made substantial impact in biofuels and energy. There's been a lot of licensing activities that have come on, lots of startups that have come on from those national labs. And then we also got bio-based chemicals and materials and ag and food systems. I will say some of the most significant work that will be impactful in the near term is the work that we're doing across the national lab landscape in soil microbiomes, looking at carbon, nitrogen, and phosphorus cycling through them, looking at some deep sequestration and root phenotyping systems, and engineering plants such as switchgrass, miscanthus, and even poplar so that they become super sequesters of carbon into the soil as a permanent soil amendment. And then, of course, the ABPDU has supported companies across its entire gamut, and the Genome Institute has done the same. So just to finalize it and give it over to Glenda, in terms of accelerating the bioeconomy to 2030 and beyond, I think we are going to be part of the solution here. We're not going to do it. We have to work with industry to take it to scale. What the national labs do best is focus on national science priorities, could do the fundamental science and engineering to prove that they can work, and then hand them off to industry so they can get to the market as fast as possible. And it's not just the national labs. We also work with the universities. A lot of us are managed by the University of California Office of the President. And so there's a lot of networking that goes on within the UC system itself. And it creates a really integrated, synergistic environment where we can span open and closed environments, different heavy metal capabilities like beam lines, and do that work with the universities to really accelerate innovation. And so it's a thriving ecosystem, and I think we're open for business with Texas as well. You can come on in and use us as much as you want. We work with a lot of Texas startups. Sandia has done an incredible job with geothermal and geohydrology with some Texas startups and some mining, like horizontal drilling. And so with that, I'll turn it over to Glenda.
I'm Glenda Humiston. As Wes told you, I'm the Vice President of Agriculture and Natural Resources for the University of California System. In that role, I serve as the Director of Cooperative Extension and the Director of our Agricultural Experiment Station. California is one of 8 states around the nation where cooperative extension is actually system-wide. In fact, one of the 4 bullet points in our mission statement is to help California enjoy economic success in a global economy. I share that because sometimes people think we only work with farmers, and that is far from the truth. We work with farm, forestry, fisheries, rural communities, urban communities, and in this case, working very closely with economic development partners and a wide array of folks who are trying to stand up our bio-based products manufacturing in California. And the labs are certainly a very key part of that, as are many aspects of the UC system. This is the system I oversee, which includes offices serving all 58 counties. And by the way, there's somebody like me in every state in the country. All 50 states and our territories each have land-grant universities with this type of program. So when you go home, please look up those folks because they can be a real valuable asset to what effort you're working on. As you can see from here, we try to scatter all over the state our research extension centers. We've got 10 of them. We've got folks on 9 of the 10 campuses right now. I was very excited just a few weeks ago to sign the papers for my first ever specialist at UC San Diego in their supercomputer center. Increasingly, we're doing more and more work with not just big data crunching, but the artificial intelligence needed to move these programs forward. And then, of course, I've got 17 statewide programs and institutes, amongst them over 18,000 volunteers. And these folks are critical. Not only do they volunteer specifically for programs, but as we're trying to do things like activities in our new policy institute to get legislative support for the policies we need to stand up manufacturing, they can be very powerful voices as we move on that. So I'm just going to real quickly remind everybody that bio-based products is not really a new thing. This has been around for quite some time. USDA has had a bio-preferred program for over 20 years. Not many people know about it, but it's there. It's doing some great work. This report that they just put out in 2024 shows that it's still growing. That whole portion is growing. $25 billion increase despite the pandemic, and that's a big deal. A lot of jobs, almost 4 million, plus our environmental impact, and then the key sectors that are affected by it. This is important because we in California have long recognized we have got to stand up a bio-based products manufacturing sector for several reasons. First of all, a lot of jobs, a lot of economic development. But in our forest, our extremely unhealthy forests, because they have far too much growth, it's where we need to find a home for biomass, and a home that could be profitable, or at least break even would be one of our goals, but profitable is better. Same thing with our agricultural biomass, and recently, our cities are now under a new law that requires them within the next few years to send absolutely no green waste whatsoever to landfills. So they too need a home for that type of biomass, and we're looking for different ways to do it. This was a bill that came out a few years ago focusing on advanced wood products. We've had a joint institute working on many options, but we're looking way beyond that. We're looking at bioplastics, packaging, cellulosic nanofibers, frankly, anything that can utilize biomass into a high-value product. That's what we're interested in. And that includes hydrogen. In fact, I was just looking over the report that Wes and John and others were involved with Harris and Cindy Chen, a couple of our cooperative extension folks, on a biomass to hydrogen strategic plan for the Riverside San Bernardino area. That's a high priority area in California with partners like the ports of LA and Long Beach and the distribution centers in the Inland Empire, which have billions of products moving through them every single day. And the diesel trucks going back and forth between the ports and those distribution centers are the single largest source of pollution in that region. They'd like to get them on something like hydrogen. We can make hydrogen for biomass. So we're looking at that. That's one of just a few examples. Now, I know I violated PowerPoint good etiquette here. There's way too many words on that slide. I'm not asking you to read them all. The reason I went ahead and left them there is that every single one of those things up there is a state program that has been passed by the legislature. It has received funding. It is functioning. It is a lot of different ways we are trying to stand this sector up. The thing right now that's probably holding us up more than anything is just getting that middle. We've got markets. The products themselves are fairly mature. Yes, more research and development can put new products out, but a lot of them are already available. And we've certainly got the biomass, as do many states. Trick is, how do we make all that work? So we've now, as a state, been putting out a more strategic effort, almost an industrial policy, although most folks don't want to call it that. This is our California Jobs First strategy that was just released by the governor a couple years ago. It's now in its second cycle of funding. And if you'll notice the areas, strengthen, accelerate, bet, which is where they're trying to identify, places for invest now, places to invest for the future. You'll see working lands and water in all three areas. You'll notice I circled those. You'll also see some gold stars there. Everything I've circled or starred there in yellow is part of the bioeconomy or supports it. Things like the hydrogen, the carbon management, education, workforce. There's a lot of jobs coming out of this. Water. If we can get healthier forests in our Sierras, we could produce as much as 10 to 15% more water for the state of California, a state that desperately needs that water. New tools, new support. Blake up here is, as you heard, Berkeley Lab. They're part of a partnership on this virtual institute on feedstocks of the future. We're trying to really to drill down even to the molecular level eventually on the different types of biomass. Biomass is not one thing. There are many, many, many different types. Each of them has a highest and best use. We want to start getting much more effective and efficient at that. ARCHES is a $1.2 billion program in California. That is a public-private partnership, over 400 public-private partners looking to really get that hydrogen equation going. We've got entities like AAA has paired up with Blue Forest to finance things like this, as has Impact Investment and RCAC. These are folks that are trying to find new ways to finance. The reason AAA there is COIN, the California Organized Investment Network, is very interested in financing anything to do with forest management, forest health, and bio-based products. So we've got a lot of different ways we're looking at this. In addition to that, we're organizing regional efforts. This is the Northern California bioeconomy, and you'll see a lot of different partners there. In fact, this is only a few of them. There's many, many more that I didn't have room for their logos. That's the problem when you start putting logo soup together. You start getting it a little too busy. But these are key ones. You've heard from Blake in the labs. I think you're going to hear from Karen Warner lately, who's doing some amazing work with Beam Circular. AgStart, the plant, I'll mention that in a second. The universities, the incubators, all of these folks are critical partners. And again, this is mostly just the NGOs, the universities, and government. I didn't put a lot of the private sector ones there, but there are literally hundreds working with us in this region. There's a lot of desire to see where we can find synergies and leveraging. We're talking about things like hub and spoke systems to really leverage how we move the biomass in a more effective way. The plant is something that we're in the final stages of, hopefully, fingers crossed. We're in due diligence at the moment. we were talking about actually building this from scratch. And with a little bit of luck, we may be able to actually purchase a facility that is almost exactly this, that already exists, which will save us several years and a couple of $100 million, which doesn't break my heart, by the way. This is critically important to the bioeconomy. This is the type of facility we need that will enable us to start scaling up, particularly some of the newer type products along cellulosic nanofibers and bioplastics and anything that requires that type of chemistry. This is really allows us to do that. So we're very excited about this and hopefully going to be moving that forward very fast. And it's also a place that our academics and our researchers from any source, public or private, can bring their intellectual property, their idea that they do want to commercialize, and actually find a place where they can start doing that path down the commercialization road, the scaling up, the proof of concept, et cetera. Almost near the end here, because I'm going to leave a couple of minutes in case there's a couple of questions. We are increasingly partnering up with a wide array of international partners. We have MOUs with everybody you see here on a wide range of different programs. Some of them are like Denmark, where we're working on dairy waste management, including things like capturing the methane. They're world class in that. I'm a big believer in not reinventing the wheel or duplicating what somebody else has got going on out there. In fact, I just signed an MOU last fall with a consortium of universities from the Middle East and North Africa who have been specializing for decades on salty soils, brackish water, dryland farming. We're increasingly needing to do that in parts of California. Why start from scratch? If there's partners out there, things like New Zealand, we're working with them because their seasons are opposite of ours. We can double time our plant breeding doing that. So there's a lot of partnerships internationally that are really valuable that we're pursuing. This is actually my last slide, but it's the one that kind of sums it up, because I'm not really talking today about the research and development. We do tons of it, and you saw what the labs do. We're thrilled to have the national labs as part of our University of California system. But what is really valuable is the fact that we are really trying to tap into that whole system, the labs, the campuses, UC-A&R, everything else that's involved with it, to really push the bioeconomy, to be smart about it, to be strategic. And what that means are these pieces here. These are the recipe, frankly, at least as far as I can tell. We've got to have the economic development strategies. You saw a few of those here, such as Jobs First. We've got to make that investment, not just in the research and development. We definitely need that investment, and we tell our state legislature that all the time, and they mostly listen. But also the investment for like early stage and middle stage and the commercialization as it unfolds. And training for the workforce, regulations and policy. We're really working on trying to get things like where we have existing industrial sites, getting expedited general permits, and really getting definitions cleared up. And then, of course, those public-private partnerships. They are critical. And I would even say it's a three-legged stool, because all too often we think public-private, and we don't always think about all three. Some people leave out one: academia, government, and the private sector. So that's how we actually put our proposals together and work on this. I want to stop there. We got a couple minutes if there's a question for Blake or myself. Yeah, that's one of the tactics and strategies we're looking at. The reality is virtually any type of biomass, and I'm not so familiar with municipal, that might be a different creature, but ag and forest, you cannot haul that biomass more than about 40 or 50 miles and have a hope of anything penciling out. That's just the reality. So what we're looking at, and the good news is, or good news, bad news, is every cloud has a silver lining and vice versa. We've got hundreds of existing industrial sites up and down the Sierra and the Valley floor. They're there. And they're in various stages, but the bottom line is they're not pristine land, they're industrial sites. And if we can figure out how to make what airlines have perfected, hub and spoke, so that we may have several sites where biomass is being brought in that 40, 50 mile radius, and then do the first 2 or 3 stages of processing. If it doesn't matter if you're making cellulosic nanofibers or bioplastics, that's a 30, 40, 50 stage process. But the first 2 or 3 are pretty much that initial breakdown. So if we can have like these mini campuses out there that do like initial sort, highest and best use of different, and then do some initial breakdown, you can then haul that feedstock a lot further. And if several are feeding into one manufacturing campus, you start getting economies of scale. We as a state have typically focused on putting our resources and energy on 1 or 2 types of use of biomass that will never pencil out. We've spent decades burning it up for electricity. That will never pencil out. But our legislature passes legislation that requires people to do it. That has been a real hindrance. And I myself have a very mixed emotion about biochar. I think when biochar is made as a byproduct of something that creates hydrogen or biofuels, yay, use it. But the idea of producing it for itself is just ridiculous. But it has become a religion for some folks. And that's a problem because it will not pencil out produced for its own sake. And I think that has held us back. We're getting people past that. We're now getting the economic development entity seeing this as an opportunity for jobs and economy and profit. So I'm over my time.